So I don't know if any of you just felt quite the way I did, but it's always interesting for me, being on the tech side of the house, to be working with an executive vice president who's actually a closet geek. So if you couldn't tell that, Regan's actually much more into the tech than than he frequently lets on. I wanted to have a conversation with you a little bit about where things are going in our world. We are very much seeing flash taking over. I know, John made the point that he's still got a lot of spinning rust in his world, and that's certainly true. People aren't just, unless somebody in here can tell me differently, people don't just generally, throw hardware out that's currently running, right? Most of your bosses will not thank you for throwing away something that's currently working in your environment. Yeah? But what we do see moving forward is that more and more people are moving to all flash platforms. And there's a number of reasons for that, but one of them has to do with just the density that you can get to in terms of the storage capacity per rack is driving people. The power and cooling mechanisms, it's not just the performance. Yes, flash is faster, right? But the fact that you can fit what would normally take multiple racks of storage capacity into a partial rack using flash, and the fact that it takes so much less power and so much less cooling, right, makes it a very, very compelling statement for people, right? And the costs now have come down to where it's pretty much, on par in terms of per terabyte costs. I'm going to make a prediction to you. I'm not a futurist. I don't generally do predictions, but I'm going to make a prediction to you that's just based on cost of manufacture. When flash gets to be 3 times the volume of spinning disk, you're going to see spinning disk exit the market, right? Not because people wouldn't still buy it, but because it's going to be a cost of manufacture issue. As the volume drops, the cost of goods goes up. There's only 3 manufacturers left making spinning disk, right? Basically, you've got Toshiba, you've got HCSG, Western Digital, right? And and beyond those 3 people, there aren't people making spinning disks anymore. So you're going to see that shift, right? And flash is going to come in. Well, guess what? Flash is also going to get faster because there's NVMe coming, so non-volatile memory express, okay? One of the interesting things that Regan mentioned to you is that networks have become more visible, right? And that's a challenge for us, right? So when the end devices speed up, when the latency drops, the network in the middle becomes visible. We didn't used to be that visible. When it was tens of milliseconds in a spinning disk, right? 5 to 8 milliseconds, as long as you're talking about the cache on the controller, right? But as soon as you went to the platter, you're talking a much longer speed, right? So those became, critical issues for us over time, and now we're becoming more visible. So we need to make that change. And I don't think it's any big surprise that most of the respondents think that complexity in IT is getting bigger and bigger, right? So it's going to continue driving more innovation for you, more applications for you, but that's stuff that you guys have to look after. So in that space, one of the things that we did was we ran a survey, or the company that we're working with here ran a survey talking about modernization. And so they talked to 100 plus customers, as I recall, right? And one of the things that they said was, okay, are you actively modernizing? Sure, we're actively out there. We're trying to modernize our environment. That's absolutely true, okay? But how certain are you that this is going to meet your needs? Because one of the most critical things that they all said was, we need to share data. We need to share data across groups. We need to share data across agencies, right? We need to be able to do that. And how do I match those 2 things? It was one of the things I was asking Donna this morning, right? How do you match the scale? Because God knows you people in the government space deal with a level of scale that none of my commercial customers are actually coping with, okay? Not yet, anyway. And some of the agencies are seriously in that space. But then you have, the need to share data between groups, but also to firewall between groups, right? Not every mission needs to know what every other mission is supposed to see, right? So those are challenges, right? How do you get access to it? How do you get through that? So yeah, everybody believes that they're modernizing, but not necessarily that it's going to meet the scheme that they need. Well, now what do? We throw in yet another flavor into the mix. So the slide that's up is one from Intel. It talks about their 3D crosspoint. There's a number of variants for the technologies, and whether it's Samsung's 3D NAND or so on, that's not the issue right now. I think one of the issues that you're going to deal with is cycle times. What do I mean by that? Looking around the room, the majority of you would appear to be, if I use the polite term, of a vintage, where you can remember that the time frame that it took us to go from 5,400 RPM drives to 7,200 RPM drives was about 10 years. And then about 6 years to go from 7,200 RPM drives to 10,000 RPM drives, right? And then the brief flirtation with 15,000, the vague look at 20,000 RPM drives, and so on, right? My point around this is you're not going to get 5 to 6 year cycles. It's not that you were sitting still with your feet up on your desk, right, not doing anything between the technology cycles. There was a lot going on, right? But you had time to absorb, you had time to consume, you had time to figure out how things fit, how to best adjust. We are now in a situation where for the first time in the history of external storage, a variant of Moore's law begins to apply to external storage. You're going to be looking at 18 to 24 month cycles, right? And at a device level, this is getting really interesting, right? Because a single NVMe physical device today, right, what you would think of as the chip interface to it, right, that's a sub 20 microsecond threshold. Not milliseconds, not seconds, right, microseconds. And the next iteration of the technology is currently testing out in silicon at sub 10 microseconds, right? And so capacities are going to go up, latencies are going to drop. These are potentially really good things for you, really cool things for you, right? Because you're going to be able to do things with this, yeah? And one of the things that comes out of this is, the write thresholding limitation appears to be going on. When they talk about high endurance, there's discussions that say within NVMe or within the 3D crosspoint architecture, you may not actually have to replace cells within the life of the storage. So, why does it matter? What's it going to do for you? Well, some of you may be in the space where you or your kids deal with computer graphics cards, right? Maybe you do some gaming at home or something of that nature, right? There's been a shortage, right? And the shortage in graphics cards, and you're laughing because you already know where I'm going with this, the shortage in graphics cards had in part to do with the fact that people were using it for cryptocurrency mining, right? And I mean, like literally you could walk into the local store, back home it's Fry's, and you walk into Fry's and there's like bare shelves, right? And the few components that are still left, they've marked up the price, significantly, yeah? Well, the reason is because those, whether it's NVIDIA or whoever that you're using, the GPU cores and those things, those are just big floating point engines. The eye candy we all go pay $20 to see in the movies, it's all math, yeah? It's all math. But now think about this. We're talking about the ability to reduce the latencies. We're talking about the ability with NVMe to have parallel queuing in the environment. So imagine, for thread analysis as an example, right? What if you could stream 30 parallel queues or 64 parallel queues to NVIDIA chipsets running a couple hundred cores of these GPUs, right? And if the software is smart enough to decompose the problem to begin with and then aggregate the response back, right? And the software is going to be the long pole in the tent. Rule 2 of IT, software is always the hard part, right? Software should never have been called software. Software should have been called difficultware, or not as easy as you thought ware, or greatly underestimated resource and scheduleware or something, but not software, right? So, where do we get with that, right? We get higher performance, we get higher throughputs, right? Congestion matters because you need access to the data. You need to be able to get the response back, right? So one of the things that we've seen in this environment is that the network becomes visible, the network begins to matter. The interfaces to the network matter. So the cards that sit in the servers, they're matched to the switches in the middle, right? The match to the interface on the storage, it matters. As you reduce latency in the environment, right? What you see is, and the chart that you're seeing in front of you at the moment, is taking the same exact storage with an 8 gig interface, right? And then switching out the switch and the adapter in the servers to 16 gig, you get a drop in latency, right? So do it again to 32 gig. So when you're sitting around saying, oh, but the storage that I've got, the components that I've got in my environment, I don't need this stuff yet, right? I don't need this higher performance. That's one of the mantras that I get from people. You guys, you're talking, Regan's talking about 64 gig. I mean, come on, I don't have anything that's, you will. But my you will. Why do I say that? Because 39 years at this has taught me one thing. At every iteration of technology, the application guys always figure out how to consume all the performance the infrastructure team exposes to them. I mean, come on, folks. In your history, in your career, have you ever once had an application owner come back and say, hey, John, you gave me way too much CPU. Here, take some back. Right? No, seriously, Mike, it's just way too much memory. Crystal, it's too much storage capacity. Here, take some back. When? Never. Never. And they bring you more features, more functions, better performance, right, over time in the application base, right? But never do they consume less resource, right? And so we think it's highly unlikely to happen here too. So NVMe started off on hardware inside servers, right? What you saw in the market, so it was basically the E was PCI Express, and an expansion of memory inside the hardware of the platform, inside the server, right, was the goal. Slightly lower latency, or sorry, slightly higher latency than the DDR, right, but at a much lower cost. So how do I expand that model, right? But then when you need a shared environment, right, put it into the storage, treat it as a storage application. So what you see is vendors putting NVMe drives in the back end of the storage, but still talking SCSI on the front end, right? NVMe over Fiber Channel, which is the step that a couple of companies have taken, and there's commercially shipping product that's been out for about 5 months now, is what you're beginning to see. Now, all the storage side of this is cool. It's good on the back end. What makes this a major shift for you folks is for the first time in 30 years, we are about to change the interface we use to talk to storage. The first time in 30 years. Okay? Now, SCSI's been a good friend to us, and it's been a good tool. And for some of you who can remember the Shugart Smart interface that was the precursor to it, right, it goes back even farther. But it was defined a long time ago. And there's a bunch of things in that 250 command set, right, that you don't use anymore. It's been a long time, probably, since any of you configured a printer or scanner on SCSI, right? But all the code's still there, right? NVMe, 13 commands today, right? It'll probably go up a little bit, but here's the thing about that. It's a drastic reduction in the overhead on the CPU, right? We're looking at, depending on who you're talking to among the server teams, between 40 and 80% reduction in overhead on the CPU, which means you can do more with that CPU. You can do more with the server, right? The optimization of that software stack, the reduction of that software stack, that's going to be a significant benefit to people, a really significant benefit to people in ways that we can't even think of yet, right? And one of the reasons we're pretty excited about this within our company is because you don't have to rip and replace your infrastructure. If you're running what we refer to as Gen 5, so 16 gig, right, or Gen 6, 32 gig fiber channel platforms in your environment today, they can already carry NVMe. You need a Gen 6 HBA in the server, right, to initialize the stream because it is a different protocol stack, right? But to us in the fabric, it's payload, right? We carry it. We're good with that, okay? So you can run concurrent traffic, which means the same HBA, right? Right, so our friends at ECD can run both SCSI and NVMe on the same HBA across the same switch to two different targets. How's that going to be useful to you? Well, one of the things that you heard me say earlier this morning is that every application owner I've ever met thinks his application is the most critical thing in the world, yes? Every application owner in your environment, I will argue, wants the bright, shiny new toy. Thinks you deserve it, right? You folks have to be the adult supervision in that conversation. So which applications in your space, or when an application comes up, when the application owner wants this performance or needs this performance or can prove the need for that performance, how do you get them over? How do you migrate them? How do you move them? So we did a demonstration at VMworld, and I want to be very, very clear with you, very upfront, truth in advertising. This was a rigged demo, okay? It was a rigged demo. It was not something you could actually buy today, right? Because my colleagues at ECD, at the Emulux division, did the VMware code for it, right? So it's not production-ready code from VMware yet. The demonstration we did was take an application, currently talking to a SCSI LAN, and just using DRS, do a live migration of it to NVMe. Show me that migration in any other technology. And all you have to do is connect the new NVMe-based storage with a new NVMe-based interface to your existing fiber channel SAN fabric, right? So that's all to the good. Visibility. Regan was talking about analytics. So for those of you that have known Brocade for a long time, or the Brocade division of Broadcom, we're geeks. We've been geeks for ages, right? So we do interesting things, like we build into the silicon the ability to measure every frame on every port in the switch. We count everything, right? Why? So traffic patterns, right? DC is a lovely place to talk about traffic patterns, right? Because you guys live with one of the biggest parking lots, right? Which you kindly term the Beltway, right? That exists, okay? When you look at traffic patterns, sampling rates are a fine thing, and that's what most technologies use, sampling rates. Don't take my word for this, by the way. Go ask your network teams. Ask them what sampling rates they're using. Because on a big core platform, a default might be 1 packet in 8,000. Aggressive might be 1 packet in 1 to 2,000, okay? And for long-term studies, that's fine. You want to do a long-term traffic study on traffic in the DC area, in the DC metro area? No problem. We can do that. Measure 1 car in 100, we can tell you pretty much historically what's going to happen. On your commute in the morning, I would argue you're actually interested in events, right? Because they're going to impact your traffic pattern. They're going to impact your time to work, okay? That's why we spend the cycles we spend. That's why we put it into the hardware. That's why the visibility and the granularity of it matters. That's why we look at latency on every port in our fabric every 2.5 microseconds. Seems like overkill to you, but it lets us solve problems for you before they become super big problems. The link that's here is to a book that's available in PDF or available in the Partner Pavilion for those of you that have an interest in it. And with that, I'm going to get out of your way and lead you to the next presentation. Thanks very much for listening.